for the binder clips. And these elementary formulas. What do I get? For example, let's start with the seven measurements on the same clip. If I simply plug the numbers into a confidence interval formula, here's what I'm going to get. So these seven measurements on the same clip, we've already recorded what is their mean and their standard deviation. We have y bar that is equal to minus 0.051, and we have a sample standard deviation that is 0.0035. Now, if I simply think about plugging these numbers into, say, this confidence interval formula for a mean, y bar plus or minus ts over root n, what am I going to get? Well, I'm going to get minus 0.051 plus or minus some t multiplier of 0.0035 over the square root of 7. This thing should be, say, if I want to do 95% confidence limits for a mean. So that's what I'm doing down here. What I want is the upper 2.5% point of the t-distribution with n-1 or 6 degrees of freedom. And if I did my table work right, that is 2.447. That gives me minus 0.051. I do the arithmetic, plus or minus 0.0032. Now, the question is, what have I got there in terms of, that's an interval for what? Well, it's an interval for the mean of those, the theoretical mean of the distribution that has generated those measurements. That is this thing, and what is that thing? Well, that thing is the measurand plus the bias. And so these are limits for the real size of that single clip plus whatever bias is being made in the measurement of that clip. Of course, if the bias is 0, so if beta is equal to 0, these are limits for x itself, for the measurand itself, the size of that clip itself.